In this video, we will be looking at some advanced sequence searching techniques. The first one will be to initiate a blast search of multiple sequences through the upload of a TXT file. And the second one we'll look at is the ability to search a peptide sequence to find coding nucleotide sequences. So pull up my desktop here. As I said, one way we can introduce multiple sequences is to upload a TXT file. So in this instance, I have my BLAST tab selected. I can upload a sequence. I will retrieve that TXT file and upload it. So we can see what we have here is the list of, in this case, the 5 different sequences I want to search. The way to create a TXT file is, well, the way I do it is by using Word. I then create a header line by doing a greater than sign and then the information to identify the sequence I'm searching, doing a full return, and then putting in the sequence. And I will do that for the other 4 sequences, and then I would save that Word file as a TXT file. Then when I click Upload Sequence, I would just need to click on that document and it will upload. So only things remain for me to do are to make sure I tell the algorithm I'm giving it a protein input and looking for a protein output. And in this case, since I'm looking at some smaller sequence, I would probably want to adjust my parameters for short sequences. That's done with sequences 50 residues or less. So now I can go ahead and launch that search. And then once my answers come back, I can view them by clicking on them down here, and they will display the sequences in the order that they were uploaded. So you can see it's showing me the wild type sequences first, but it's let me know what the other 4 sequences, the identifier for the other 4 sequences. Okay, so here in the sequence tool, I can see this cartoon of the sequence I was searching for, the query sequence, and where it was found in the subject sequence, in this case between residues 29 and 51. To view a little more information about that, I can go to the subject tab. In this case, the sequence actually came from the NCBI database. A nice feature here is that there will be an identifier that I can click on and then actually to fly into the NCBI database. And here it's going to show me this information, basically the Latin name for the cotton bollworm, and I'll read all about that. So now if I go back, that's looking at the first sequence, and as I scroll down, now I'm seeing some sequences that aren't quite a full match of all 23 residues, and it shows me where in the sequence there was a mismatch. And if I'm curious on that, I can click on the subject here, see this also came from the NCBI database, and then dive in to see a little more information about this. And here I see this is actually a sequence that came from a corn earworm. Okay, so that was searching on that first wild type sequence and other sequences related to it. If I want to go to my next sequence, just simply select it. I want to upload all the results from that search, and then I would go about the same process. Didn't go through in detail, but this mutant here has a mutation in the 3rd residue there, going from a leucine to a serine. So as I did with all the other ones, I could go in here and take a look at the NCBI database information on that. And so I can click them one at a time like that. But notice that we also have associated here some organism filters. So if I can kind of scroll through here and get to a species that I'm interested in, I can now just filter by that and then bring back the 2 sequences that came from that specific species. As with any other ones, I can look at the different mismatches here. I could click on the subject sequence and then take a look at the information on that either in our database or if it was pulled from the NCBI database, turning over there to see what is found there. All right, let me pull back all the wild type answers again to show that there are a couple different ways I can download this search. If I click up here, it's going to show me the options of downloading all this information you see here into an Excel spreadsheet, which I will do. I could also download all the 117 sequences here into a FASTA file if I want to save that for later searching. But I'm just going to download this to an Excel spreadsheet. So this is a nice way to hold this information, because the data will be put into different columns that are all sortable and searchable. And as I click on this to open up what it looks like, you can see it's going to capture the cartoon of all the answers, show where mismatches were. I can come over here to see the actual sequences themselves, look for the gaps to know that those where there was a mismatch. And then as I scroll to the right, you can see some of the information that can be included if it is available for the individual sequences, NCBI identifiers, organisms, expectation value, blast scores, matches, mismatches, and alignment identity. Okay, so that is everything we're going to do about doing a search of multiple sequences in BLAST. The other one that I want to get into today is if I want to search a peptide sequence, but to look for the nucleotide sequences that would code for it. So in this instance, I'm going to bring in a peptide sequence and paste it in. The only thing I'm going to change from the last BLAST search that I ran is in this instance, I'm telling it I'm giving it a protein input, and then I want to see a nucleotide output. So with that, I will go ahead and initiate that search. Comes back pretty quickly. And then if I want to view those results, just before, I'll click on the View Results button. And once this is loaded up, it's going to show me the peptide sequence that I searched for and say, in this instance, if I want to see the nucleotide sequences coding for it, I want to look in the subject sequence starting at residue 230. Now, a 23-mer of amino acids would be coded for by a 69 nucleotide residue sequence. So when I go into subject, I want to start at residue 230 and then go up to residue 298. And then that would be the nucleotide sequence coding for it. I could copy that, paste that, whatever I would like to do.